Hi everyone, this is my poster presentation entitled Sigma Metric Scores for Routine Hematological Parameters in a Small Laboratory. As an introduction, Six Sigma Metric Score has started to be used in clinical laboratories as quality tool to monitor analytical instruments. The Six Sigma refers to a standard deviation of process that should fit within the tolerance limits of the quality requirement. Generally speaking, assay with higher sigma score represents better analytical performance and has less variability, and as a result may require lower frequency of QC. Six Sigma score has been used more frequently in biochemistry department than hematology department. The third-party QC provider for chemistry, for example Bioret, has created QC software that can tabulate and calculate sigma scores and recommend what are the best QC rules that can be implemented on analytes automatically. However, this has yet to be implemented in our hematology unit. Hence, we aim to measure sigma score for our reportable parameters using total allowable error TEA based on two quality goals. First, using desirable biological variation BV data by the Analytical Quality Commission of the Spanish Society for Clinical Chemistry, and second, Royal College of Pathologists Australasia RCPA. This actually was our first exercise evaluating sigma scores in our hematology division, and this was manually tabulated and calculated. We have chosen 9 analytes produced by our hematological instruments SysMac XN550. The 9 analytes were white blood cell count WBCC, white blood cell differential WBCD, red blood cells, hemoglobin, hematocrit, platelet impedance, platelet optical, absolute reticulocyte count, and percentage of neutrophils. We have selected one batch of QC-log XNL SysMac Corporation, which included all QC levels, and have tabulated the data to calculate the statistical indices such as mean, standard deviation, and coefficient of variation for all the selected analytes. The QC materials were run twice daily, and QC acceptance was based on our quality assurance procedure. Since we use sigma calculation formula, which is sigma equals to total allowable error minus bias divided by CV, therefore we have decided to use bias value for each analyte using bias from our EQA RCPA. The bias data were extracted during the same period the internal QC were tabulated. The Six Sigma score that is more than 3 is considered as an optimal performance. From the table shown here, sigma scores in green boxes have sigma score more than 3. The reason why we chose quality goals of Spanish BV and RCPA because both have complete total allowable error values for all of our selected analytes. In general, we achieve sigma scores more than 3 for analytes that have higher TEA value, probably because most of our analytes CV are low. TEA for RCPA for most analytes are higher than TEA for Spanish BV, except for retic absolute count. As a result, the sigma score for retic absolute count were less than 3 for all QC levels. However, this was also contributed by higher CV values for reticulocytes. We noticed that in general, RCPA has different TEA values for lower limit of QC level, but similar TEA values were applied for all QC level for Spanish BV. We also observed that platelet impedance and platelet optical demonstrated the poorer sigma scores 1.3 and 1.9 respectively for low QC level compared to other analytes and levels. Interestingly, the WBC differential counts all showed sigma scores of equals or more than 3, including WBC count and WBC differential. However, complete data was not shown. The biggest difference of average sigma scores between Spanish BV and RCPA were observed in RBC, hematocrit, and neutrophil percentage. Apparently, there was a large gap of TA values between TA of Spanish BV and RCPA for these 3 analytes. As a conclusion, we are able to have an overview of our quality performance by utilizing the sigma metric score. Further analysis is needed to utilize this finding to help us in setting up specific QC rules for our hematological parameters. With that, thank you very much.